morning. We have moved to chapter 3, Electrochemistry. What is electrochemistry? I am going to combine electrical energy and chemical energy. So I am going to make use of electrochemical reactions for useful purpose. See, from the spontaneous chemical reaction, energy is liberated. This energy is used to produce electricity. What is spontaneous chemical reaction? Chemical reaction which occurs spontaneously without any pause. So from spontaneous chemical reaction I am getting energy. This is used to produce electricity. Now this electrical energy which is liberated from the spontaneous chemical reaction is used to carry out non-spontaneous chemical reaction. So a spontaneous chemical reaction is happening, from that energy is liberated, that energy is used to carry out non-spontaneous chemical reactions. Also, your electrochemical reactions are used to produce metals, sodium hydroxide, fluoride, chloride, etc. In our daily everyday life, we will be using battery and fuel cells. What is the role of battery and fuel cells? They will be converting chemical energy to electrical energy which can be used in all instrumental devices. The energy produced from electrochemical reactions is highly efficient. Means the pollution produced by your electrochemical reactions are less when you compare them to a normal chemical reaction. So electrochemical reactions are eco-friendly because they are going to combine your electrical energy and chemical energy. So the amount of pollution is less. So they are eco-friendly. Then transmission of sensory signals from cell to brain or brain to cell. This vice versa, this reversible reaction is very important for communication process. Even this reaction is of electrochemical origin. So done. We have seen the introduction part. What is electrochemistry? A combination of electrical and chemical reactions to give me useful work is called as electrochemistry. For this, I have to carry out spontaneous chemical reaction. I will be getting energy. That energy is used to produce electricity, as well as the energy produced from spontaneous chemical reaction is used to carry out non-spontaneous chemical reaction used to produce metals, and they are involved in the transmission of sensory signals from brain to cell and cell to brain. And your battery and fuel cells will be converting chemical energy to electrical energy which can be used in many instrumental devices. And energy produced by these electrochemical reactions are very efficient. They are less polluting, so they are eco-friendly. Now coming to Daniell cell. About Daniell cell we have already studied in 11th standard. I think you all know about the instrumental setup. We have a copper electrode dipped in copper sulfate solution, zinc electrode dipped in the zinc sulfate solution, and the two will be internally connected by means of U-shaped salt bridge. See, what is the role of a Daniell cell? A Daniell cell converts chemical energy to electrical energy. Where does they got energy for this conversion? This energy is obtained from redox reactions. Hope you know about redox reaction. Redox reactions are otherwise called as redox coupled reaction, where both oxidation and reduction happens. So what is the role of a Daniell cell? A Daniell cell uses energy from the redox reaction to convert a chemical energy to electrical energy. So any device which use Daniell cell is called as galvanic cell or voltaic cell. I know what is the role of Daniell cell because Daniell cell is converting chemical energy to electrical energy from redox reaction. So all the devices which make use of Daniell cells are called as galvanic cell or voltaic cell. See, your galvanic cell or voltaic cell will be having an electrode potential of 1.1 volt and the concentration of zinc and copper will be unity. So what are galvanic cell or voltaic cell? A cell which uses Daniell cell for converting chemical energy to electrical energy, whose electrode potential is 1.1 volt and the concentration of zinc ion and the copper ions is unity. This is called as galvanic cell or voltaic cell. Now, apart from this electrode potential, I am going to apply an external voltage. External voltage is applied to galvanic cell and this voltage is increased slowly. What happens? The reaction continues. How long the reaction continues? The reaction will be continuing till an opposing voltage is obtained. The opposing voltage unit is 1.1 volt. Whenever an opposing voltage is applied, then the reaction stops. There is no flow of current. Okay, done. I know what is a galvanic cell. A galvanic cell uses Daniell cell. Okay. So I am going to apply an external voltage. The reaction will be continuing. If the external voltage is equal to 1.1 volts, then the reaction stops. No flow of current. Now further I am going to increase the external voltage. Here the reaction starts again, but this time the reaction proceeds in the opposite direction. Okay. This stage your galvanic cell or voltaic cell becomes electrolytic cell. What is the role of electrolytic cell? An electrolytic cell uses electrical energy to carry out non-spontaneous chemical reactions. Okay then. There are three conditions. If my external voltage is equal to 1.1 volt, no flow of electrons, so no current flow. If my external voltage is greater than 1.1 volt, then electrons will flow from copper to zinc. We know already that the current flow is always opposite to the electron flow. Since the electrons are flowed from copper to zinc, what happens to the current flow? The current flow should be from zinc to copper. So in this case, your zinc will be deposited in the electrode and copper will be dissolved. Done. What is the third case? In the third case, my external voltage is less than 1.1 volt. Here what happens? My electrons will be moving from zinc to copper. If the electrons are flowing from zinc to copper, what happens to the current flow? Then the current flow will be from copper to zinc. Here, zinc dissolves and copper will be deposited. So, these are the three cases of Daniell cell. We know what is the Daniell. So, in Daniell cell, the Daniell cell is used in the galvanic cell. Any device which use Daniell cell is called as galvanic cell or voltaic cell, whose electrode potential is 1.1 volt, concentration of copper and zinc will be unity. So, three conditions are very important. In the first condition, external voltage is equal to 1.1 volt, no current flow, no electron flow. If external voltage is greater than 1.1, then electron flow is from copper to zinc. If external voltage is less than 1.1, then what happens? Electron flow is from zinc to copper. Always current flow is opposite to electron flow. Done. So, we have already discussed about galvanic cell. Any device which use Daniell cell is called as galvanic cell or voltaic cell. At some point of time, your galvanic cell will be becoming an electrolytic cell. What is the role of electrolytic cell? An electrolytic cell uses electrical energy to carry out non-spontaneous chemical reaction. See, we have already seen about Gibbs free energy. Gibbs free energy, which is obtained from spontaneous redox reaction, should be converted to a useful electrical work. That is, it can be used to run a fan, used to run motors, used in heaters, room heaters. It can be used in geysers. So whatever the Gibbs free energy which is liberated from these reactions should be converted to a useful electrical work like running a motor, working of electrical fan, geyser and room heater. We know about Daniell cell. In Daniell cell, redox coupled reaction should happen. That is, in one half of the cell oxidation should happen, in other half of the cell reduction should happen. So this is reduction half and oxidation half. So in reduction half, what happens? Copper is reduced. This is anodic end. It has got negative potential. What is the other half of the Daniell cell? Where your oxidation happens, zinc is oxidized. This end is called as cathode end and it has got a positive potential. So, in different portions of the Daniell cell, your two half reactions will happen. Your oxidation and reduction happens in two half of the Daniell cell. Now, these two portions of the Daniell cell is called as redox couple. By having this principle, by using this principle, I can construct n number of different patterns of Daniell cell by different combination of half cells. By using different combination of my reduction and oxidation, I can construct n number of different pattern Daniell cells. Okay. See here, now I have got an electrode, I have got a beaker, I have got two half cells. This is one half, this is another half. Electrodes are dipped. In where electrodes are dipped, the electrodes are dipped in the normal electrolyte solution. The two half cells are connected to metallic wire by means of an voltmeter. What happens to the two half cells? They are connected by means of metallic wire through voltmeter and to the switch. This is called as external circuit. What is this? This is external circuit. Then your two half cells are connected, or your two electrodes are dipped in the same electrolyte solution. They can be connected by means of salt bridge. Your salt bridge connection is said to be internal, while your external connection is said to be your voltmeter and your switch connection. Okay. Then in an electrode and electrolyte interface, I mean in electrode and in electrolyte interface, what happens? Some of the metal ions from the solution will deposit to the electrode. As a result, the electrode is negatively charged. I am going to tell you about two cases. I have got electrode electrolyte interface. In electrode electrolyte interface, first condition, my metal ions will be depositing at the electrode from the solution, then the electrode is negatively charged. This is not the only case. Sometimes what happens, some of the metal ions will move from electrode to the solution, making the electrode negatively charged. Okay, then I have told about two conditions. What is the first condition? Electrode from the solution deposited on the electrode. I mean your ions from the solution on the electrode, making it positively charged. This is the first case. In electrode electrolyte interface, metal ions deposit at the electrode from the solution, it is positively charged. What is the second case? In the second case, metal ions from the electrode move to the solution, making it negatively charged. Now, what is the third case? At equilibrium, the separation of charge is based on the tendency of opposing reaction. Either my electrode will be positively charged with respect to electrolyte, or it can be negatively charged with respect to the electrolyte. So at equilibrium, the separation of charge is based on the tendency of two opposing reactions. Now, what is the potential difference between your electrode and electrolyte? The potential difference between the electrode and electrolyte is called as electrode potential. That is called as electrode potential. When the concentration of all the species is unity, then that electrode potential is called as standard electrode potential. You know what is electrode potential? Potential difference between your electrode and the electrolyte is called as electrode potential. If the concentration of all the species is unity, then it is called as standard electrode potential. So you understood the introduction part. We know first what is an electrochemical reaction, what is the application of electrochemical reaction, what is the Daniell cell. A Daniell cell converts chemical energy to electrical energy by means of redox reaction. Any device which uses Daniell cell is called galvanic cell or voltaic cell, whose electrode potential is 1.1 volt and the concentration is unity. Okay. Then we saw three cases. When external voltage is equal to 1.1 volt, no electron flow, no current. When it is greater than 1.1, then electron flow will be from copper to zinc. When it is less than 1.1, then the flow of electrons will be from zinc to copper. Always current flow is opposite to electron flow. Okay, done. Then where Gibbs free energy is used to do useful electrical work. Okay. Then we saw about the two halves of the Daniell cell. One is oxidation half and reduction half. They will be in two halves of the Daniell cell. So what is that called? That is called as redox couple. Redox couple. Okay. Then externally they are connected by means of voltmeter and switch. Internally they are connected by means of salt bridge. If you are going to keep two electrodes in the same electrolyte solution, then there is no need for salt bridge. Then we saw two cases when metal ions are deposited at the electrode. When metal ions are moving from the electrode, what happens to the electrode potential, whether it is positive or negative. Then potential difference between electrode and the electrolyte is called as electrode potential. When concentration of all the species are approaching unity, then it is called as standard electrode potential. Yes. Yeah. So in galvanic cell, the potential difference between two electrodes is called as cell potential. It is indicated by the unit volts. Difference between electrical potential of cathode and anode is called as electromotive force when no current flows. I have already explained you what is cell potential. Okay. So potential difference between two electrode, between your positive electrode and a negative electrode is called as cell potential. We already seen what is PD, that is potential difference between electrode, electrolyte we have seen. Here potential difference between one electrode and the other electrode. This is between two electrodes. Okay, remember carefully, between electrode and electrolyte, and this is between two electrodes. This is called as cell potential. Difference between electrical potential of cathode and anode is called as electromotive force. There is no current flows. When I switch on the voltmeter, when I switch on the current, what happens? Electrons will be moving from negative electrode to positive electrode. Which is negative electrode? Negative electrode is nothing but your cathode. Which is positive electrode? Your positive electrode is nothing but your anode. So when current is on, electrons will be moving from cathode to anode because electrons are negatively charged. They are moving towards the positive end, that is towards the anode. We have already discussed when the flow of electrons is from cathode to anode, then what happens to the current flow? Current flow should be opposite. Current flow should be from anode to cathode. Done. So in galvanic cell, what is the experimental setup? The anode is kept in the left hand side and cathode is kept in the right hand side, and an indication of a single vertical line is showing the potential between your metal and electrolyte. If I am going to indicate one vertical line, then it is indicating the potential between my electrode and electrolyte, that is my metal and electrolyte. If I am going to indicate two vertical lines, then it is indicating the cell potential between two electrolytes which are connected by means of a salt bridge. This is called as, this condition, my EMF will be positive. This condition, under this condition, my EMF will be positive. I am just repeating once again. Difference between electrical potential of cathode and anode is called as EMF, no current flows. When current is on, then electrons flow from cathode to anode and current flow is opposite. So in galvanic cell, where anode is kept? In the left hand side. Where cathode is kept? In the right hand side. What does your single vertical line indicates? Single vertical line indicates potential between metal and electrolyte. What is double vertical line indicates? Your double vertical line is indicating the potential between two electrolytes. In this case, electromotive force is positive. So what is potential of a cell? Cell potential is equal to potential on the right hand side minus potential on the left hand side. Here, in the right hand side, I have kept a silver electrode. In the left hand side, I have kept copper electrode. So how will I make the equation? E cell is equal to potential of silver electrode minus potential of copper electrode. See, we have seen about two halves of the reaction. We cannot determine the potential of two halves of the galvanic cell. It is not possible. We cannot determine the potential of both the halves of the galvanic cell, but one can be determined with reference to the other. That is, potential of one half of the cell can be determined if you know the other. So the other should be kept as a reference. What is that electrode called? That is called as standard hydrogen electrode, whose value is known to us. Since I know the value of my reference electrode, keeping a reference, I can determine the other electrode. Okay. So what is standard hydrogen electrode? Since it is impossible to determine the potential of individual half of the cell, but you can determine the potential of one half of the cell provided you have a reference electrode. What is that reference electrode? That reference electrode is called as standard hydrogen electrode. What is standard hydrogen electrode? It is nothing but platinum electrode which is coated with platinum black. Here I need to dip this platinum electrode in an acidic solution and hydrogen gas should be bubbled through it. So this is the experimental setup. I need a platinum electrode, should be coated with the powdered platinum black, and I have to bubble hydrogen gas. I have to dip them in acidic solution. Your hydrogen electrode, the standard hydrogen electrode is indicated by platinum bar hydrogen, whose potential is 0 under all conditions of temperature. This hydrogen, since it is a standard reference electrode, it is represented as PTH2, whose potential is 0 at all temperatures. What happens to the pressure of this standard hydrogen electrode? The pressure of this hydrogen electrode is 1 bar. And what happens to the concentration of hydrogen ion? The concentration of hydrogen ion is equal to 1 mole, that is 1 molarity. That. If my standard electrode potential is having a positive value, then copper ions can reduce hydrogen ion, means hydrogen cannot oxidize copper ions. Okay. So what does this indicate? Copper can reduce hydrogen, but hydrogen cannot oxidize copper. This is the reason why copper will not dissolve in hydrochloric acid but can be dissolved in nitric acid. Why? Because nitrate ions can reduce copper ions. Okay. Coming to the second case, if my SEP is taking a negative value, then my hydrogen can oxidize zinc or zinc can oxidize hydrogen. Done? So we have seen two cases. If SEP is positive, then copper can reduce hydrogen. If SEP is negative, then hydrogen can oxidize zinc or zinc can reduce hydrogen, vice versa, both are same. If SEP is greater than 0, then always reduced form is stable than hydrogen gas. If SEP is negative, then hydrogen gas is stable than the other reduced form of any species. Okay. See, for example, there are one electrode, that is your platinum and my gold electrode can be used as an inert electrode. What is the use of platinum and gold? They can be used as an inert electrode. What is the meaning of inert? Inert, they will not take part in the reaction. They will not participate in the reaction, but instead they provide surface for oxidation reduction to happen, as well as they provide surface for conduction of ions. So that. So where your She should be used, that is standard hydrogen electrode, where it comes, you cannot determine the cell potential of both the halves of the Daniell cell. You need to know the value of one half, then only you can determine the other half. For that I have taken a reference electrode called standard hydrogen electrode. We have seen what is the positive value and what is the negative value we have seen. If SEP is greater than 0, which is stable, reduced form is stable than hydrogen. If SEP is negative, then hydrogen is stable than reduced form. We have got a tabular column in all your NCERT textbook for this chapter, that is chapter 3 electrochemistry. When you look into the table, we will be seeing that the gas fluorine has, whose value is highest. The SEP value of fluorine is highest. So what does this implies? This implies that my fluorine gas has got the maximum tendency to get reduced to fluoride ions. So why fluorine is kept in the top? Because its SEP value is the highest. Means what? the fluorine gas is having the maximum ability to get reduced. Gas is reduced to ions. So fluorine gas is the strongest oxidizing agent, while fluoride ions are weakest reducing agent. So I have told you in the tabular column, I came to know that fluorine is highest SEP. It has got highest SEP. Who is lowest? My lithium. Lithium metal has got lowest standard electrode potential. So what does this implies? This implies that lithium ion is the weakest oxidizing agent, while my lithium metal is a powerful reducing agent. So in the tabular column, when I move from top to bottom, then my standard electrode potential is decreasing. So from the tabular column, I am getting two inferences. What are those inferences? My oxidizing power is reducing from the left hand side, while the reducing power is increasing in the right hand side. Done. I have told about two extreme cases. One is your fluorine gas, which has got highest SEP. The other one is lithium metal, which has got lowest SEP. So in the left hand side your oxidizing power is decreasing, while in the right hand side your reducing power is increasing. So what is the final application of electrochemical cells? So electrochemical cells are used to determine the pH of the solution. It is used to determine the equilibrium constant, used to determine the potentiometric titration. It is used for thermodynamic properties. So what is the application? To determine the pH, to determine the equilibrium constant for thermodynamic properties as well as in case of titrations. So in the next class we will be seeing about conductivity, conductivity in electrolytic solution, conductivity in ionic solution. What is the difference between conductivity and molar conductivity? What is Nernst equation? What is Kohlrausch equation? Then batteries, primary battery, secondary battery, what is corrosion, what is hydrogen economy. Thank you.